do that, you invest it at some interest rate, right? And how's that interest rate usually quoted? I mean, how do they tell you this? An interest rate,
Isn't it like I equals PTR,
there's,
principal rate over time?
that's close to what I'm shooting for. But the R is the interest rate?
It's I equals PTR, so it's principal times the rate of interest over time.
So, yeah, and the interest rate is usually an annual interest rate, right? So when they say, in fact, I just talked to my banker yesterday. Turns out you can buy a CD now that'll get you an annual interest rate of 2%. Happy days are here again. And so the interest rates are going up, and who controls the interest rates?
The Federal Reserve.
The Federal Reserve, right. They're tasked with maintaining a good employment rate and keeping inflation from running away. They've been pretty good with the official inflation rate, although I noticed that the cost of things tends to go up, even though the official inflation rate doesn't. So in any case, compound interest. So we're going to say that if we want to grow something by R%, what do we multiply? So to grow principal, let's call it P, by R%. Well, let's say that by rate R, I'm not going to say R%. I'm just going to say rate R. Multiply by 1 plus R, right? So you have what you started with. So P times 1 plus R is what you started with plus the amount of growth. So you keep what you started with, but you get this additional amount, right? So for example, to grow by 2%, that implies R is 0.02, right? Multiply by 1.02. So you're going to get P times 1.02 is your initial P value plus 2% of P, right? So you've got what you started with plus the amount of growth. Okay, so if you want to do that twice, say over a 2-year period, you take what you had at the end of 1 year and grow it by 2%, right? So to grow by 2% over 2 growth periods. So what's a growth period? Well, for annual interest, growth period is 1 year, right? Multiply by 1.02 twice. Right, so you're going to have P times 1.02 times 1.02 again. So you had what you had at the end of the first year, you grow that, right? So that becomes P times 1.02 squared. And what's that? Well, that's a little bit more than 4%, is what we were talking about before, right? So the square of 1.02 is 1.0402, I believe. Yeah. Should we check that? We're multiplying, and I've got my decimal point here, right? Oh, 4. I had a feeling that was wrong. Sorry. But yeah, just a little bit more than 4%, right? So it's that's the effect of compounding, right? That when you grow the amount that is already grown, at the same rate, the compound rate is more than if you just grown by 2% twice, or how do you say that? More than, it's not simple interest, it's compound interest. So you grow the amount that is grown at the same rate. Now, what if your compounding period, there are n compounding periods per year, let's say, because the year is sort of the standard interest rate. So when you're quoted an interest rate, it's usually an annual interest rate, which means over 1 year, right? But if you have to wait until the end of the year to reinvest your interest, which is kind of what you're doing here, right? First you're growing by the 2%, then you're taking your interest rate and growing that too, right? But if you want to say, you know, you're a finicky investor or you're a banker trying to sell a better product, then you say, well, look, I'm going to allow you to reinvest your money 4 times a year. Quarterly is what they call that, right? Or n times a year in general, right? So what if there are n compounding periods per year? Then, if R is the annual rate, the rate per compounding period is going to be what? Did I hear that?
R over N?
Yeah, R over N. Because you just said, so if you have a, say, 12% interest rate, good luck with that. But you compound quarterly, then every 3 months, you would grow it by 3%, right? 3%, 3%, 3%, 3%, 4 times would be 12%, but it's going to be a little bit more than that, right? Because you're compounding quarterly. And so the number of compounding periods would be what? Sorry, in say T years. Well, n compounding period per year times T years will give you n times T. So you're going to get the amount in the bank at time T is going to be your initial principal times the growth factor, which is going to be the percentage interest rate per compounding period. And how many times do you apply this this growth factor in T years? And this is how many compounding periods there are, right? So n times T. So you're going to multiply by this growth factor nt times. So that's the formula for compound interest. You see that there's sort of something interesting going on here, right? That as n gets large, this 1 plus r over n, if r is fixed and n gets large, then this r over n gets small, right? So the interest rate per compounding period gets smaller and smaller if the number of compounding periods per year gets larger, but the number of factors that you multiply that by gets larger, right? So nt grows with n and r over n shrinks with n. So you have the base getting smaller and the exponent getting larger as n grows. So shall we try that with a few problems? Let's try a few problems in the book or something. Oh, we're still watching this movie. How are things going there? Oh, I will try. What? I want to get our book. Let's look at our book, which is